Hey guys, today we are going to talk about our second one, what am I trying to say here? Our second lines of concurrency. Yesterday we talked about centroids and we talked about circumcenters, and today we're going to talk about incenter and orthocenters. All right, so a few more vocabulary. An angle bisector. So if you have an angle right here, angle ABC, and you have a line segment BD, if you have a line or a line segment that bisects the angle into two congruent angles, then that would be an angle bisector. So something, a ray or a line segment or a line that actually takes your angle and cuts it into two congruent parts would be an angle bisector. Okay, so one of the two that we're going to learn about today is something called an incenter. And your incenter is the point where the angle bisector, so that's why we had to learn that stuff, the angle, that vocabulary, the point where the angle bisectors of the triangle will intersect. So when we talked yesterday, our centroid was where our medians intersected, and our circumcenter were where our perpendicular bisectors intersected. So our third one is where our angle bisectors intersect, and that has a special name called the incenter. Okay, and from that incenter, the lines perpendicular to each side are congruent. So if you can first figure out where your incenter is, and you're going to figure out where your incenter is because first of all, you need to realize that it's going to be on the segment that cut the angles in half. Okay, that's how we found the incenter. Now what you're going to do is take that actual incenter and you're going to make a perpendicular line from the incenter back to each side of the triangle. And when you do that, then and it's got to be a perpendicular, right? We got to come back and go perpendicular back to the side. What that's going to do is tell you that all of those pieces right there have to be congruent, because what you have actually done is created a circle again for the points where you touch those sides of your triangle. The incenter is the center of the circle that connects all of those perpendicular lines back. Okay, so once again, from the incenter, the lines that are perpendicular back to the sides of those triangles are congruent because they really become a radius of that circle that's inside, not the outside circle, not outside of the triangle points, but inside the circle that touches all three sides of the triangle. And those are actually called an in radius. Okay, so the words over on this side, so you've got angle bisectors. All three angle bisectors are going to meet at what we call the incenter. And then from that incenter, if you go from your incenter back to the sides of your triangle, all three of those are perpendicular back, and they're called the in radius, but they are all going to be congruent. So when we have a question like this, and it says point A is the incenter. So if I know that that's the incenter, if I can find these little 90-degree angles right here, and right here, I know that all three of those lines have to be equal to each other. So if I have two of them that are labeled with some algebra stuff, all I'd have to do is set those two things equal to each other. So, and when I do that, I can literally just say, all right, in this case, then that 5x minus 1 is going to be equal to 6x minus 3. And my picture didn't come through on this one. Sorry, my printer is not working very well. But I can take that 5x minus 1 and set it equal to that 6x minus 3, and I can solve for x and end up with x equals 2. Well, if they wanted to know what NA is, NA has to be the same length because all three of these are equal. So if you can just take the information you just solved for X, plug it into either one of these, and you can end up with your answers. So one of them, my LA, was 5 times 2 minus 1, which is 9. The other one, AM, is 6 times 2 minus 3, which is 9. So obviously, all three of these have to be the same. So we could have just found either one of those, and your answer would have been 9. Okay, perfect. All right, so as we move on here, and again, there was that website down here that allows you to be interactive with, we already talked about the centroid and the circumcenter, and this is actually, you can also do that for your incenter. Okay, and then we have the last one to talk about, and that is your orthocenter. And y'all, to be honest, I don't think you're going to be asked about the orthocenter because I'm pretty sure that they have removed this from our curriculum, but it was on the curriculum in the past, and I just get a little bit nervous. It just makes sense since we've talked about the other three. We're just going to throw this in. And again, here's your interactive website for the orthocenter if you want to practice with it. But it's where the altitudes meet. So if you have, if you find where the altitude, right, you're going to go from a vertex perpendicular down, from a vertex perpendicular, from a vertex perpendicular, where the altitudes all meet, that's where, that's called your orthocenter. But again, not really going to have very many questions based on this. What they might just ask you, it might be a definition. And remember that those orthocenters, that orthocenter could be outside of the triangle. It might be in the triangle, it might be outside of the triangle, or it might be on the triangle. And so if it's an acute one, it's inside. If it's obtuse, it's outside. And if it's a right triangle, right on, man, right? Thumbs up, right on. If it's a right triangle, you're right on it. So your orthocenter is actually going to be on that, on your triangle. So this is quick, just a little summary, again, for you to just kind of look through, look over your notes. There's nothing really for me to add here. This just goes back and puts all of them kind of back in the same one-page little compact place for your notes. Orthocenter is the one we just talked about. It's where your altitudes meet. Your incenter is where your angle bisectors meet. And remember, if you go from your incenter perpendicular back, those are congruent. And if you have your excuse me, your centroid, this is correct, m over 3 and 2/3 m. I do like to think about that though as 2a and a. It just is easier to work with. The short and the long, two shorts equal a long. And remember that your short side goes from the side to the centroid. The long one is from the centroid all the way back out to the angle. And the last one was your circumcenter, and your circumcenter was where the perpendicular bisectors of the sides all met, and that was the center of the circle that would go around the outside of your triangle. So therefore, you are equidistant to the vertices. So this is the one that you would use if you're trying to come up with that new Amazon distribution center. Okay, just a quick review on that then. And then basically that's it, y'all. The rest of the packet is homework. So we've got some homework questions here. And then notice that we also do have some spiral back questions to get us ready for our EOC. All right, thanks. Hope you guys have a great day.